Gee, I'm a tree. Okay, so today we're going to talk about our last and final transformation called a dilation. You should remember something about dilating your eyes or something if you're going for an eye exam. So if you've ever done that, sorry. What they do is they blow up your pupils a little bit. And that's basically what we're doing with our point. A dilation stretches out the position by a common factor. Now, it may sound a little confusing, but basically you're going to now, instead of adding like we did with the translation, you're going to multiply by a certain number. So, this is how they word it. You have dk, not d like Donkey Kong, but the dilation of a factor of x. And what we do, we start with our point xy, and it will become kx and ky. And all you're going to do is perform a multiplication on each part. So, there's a couple little things you need to realize, is that k can be any number. Now, when it is bigger than 1 or smaller than -1, the point will go further away from the origin. Okay? And then when k is a fraction under 1 but bigger than 0, it'll make a point go closer. And we'll see these in the example. Okay? Now, first thing I want to do is you're going to find the result of d3 on 3, -2. Now, the thing is that when you're doing this, all you have to do, you start with 3, -2, you multiply each part by 3. So 3 times 3, 3 times -2. Okay? And that'll become, 3 times 3 is 9, 3 times -2 is -6. And that'll be your point. Okay? Now, if you notice something, 3, -2 is closer to the origin. So 3, -2 would be over here. 9, -6 is going to be like all the way over here, which is sort of a little bit crazy because now that's a lot further away. Now, try one with a fraction. Basically, find the result of the dilation of a factor of 1/3 on the point -6, 9. Now, we do the same exact thing we did before. So you do -6 times 1/3, comma, 9 times 1/3. Okay. Now, -6 times 1/3, basically when you're doing this, you end up doing, when you work with a fraction, you're really dividing, so -6 divided by 3 is -2, and 9 times 1/3, or 9 divided by 3 is 3. So you get that point. Okay. Now, one last thing, negative. When you're doing a negative dilation, it's just one of those theoretical things that you really never use in life. But what we're really doing, and sometimes they randomly ask this, you're going to do the same process. But what's going to happen is the point is going to go from, we start with -1, 2. You're going to multiply each of these by -2. So -1 times -2 is 2. And -2 times 2 is -4. So this is our original point, A. It is going to change by going to 2, -4. Now, it is still further away from the origin than A is. But, however, it's not going to be on the same quadrant or the same side of the axis. It's going to be on the opposite side, but this distance is still the same. Okay, here's some problems for you to try on your own. If you have any questions, feel free to ask me tomorrow. Talk to you later. Bye-bye.